Okay, yesterday I started with the component Hive, which is like a SQL interface for your data which is stored on STFS, right? Basically, you can actually um, visualize or expose your STFS data, which is of structured data or semi-structured data. You can visualize as tables, and then you can write queries on top of that to analyze your data. Okay, that's the main use of Apache Hive, right? So, do you have any question on that? So I explained about only the table concepts in Hive. One is a managed table, another is external table. Okay, so managed or internal tables basically um, data which is stored on those tables are managed by the Hive service, which is in a default directory slash user Hive and warehouse. In its case of external table, the Hive external table, the data will be stored on user directory in HDFS. Then they will point to that user data. So then they are writing a query on this external table will go on to query the user data which is specified during the create table, um, the external create table. Right? So these are the two types of table available in Hive. Okay, so if you don't have any query, we'll move on to the next concepts, which is different join concepts in Hive. Okay, so like RDBMS, the SQL joins which we use in the RDBMS system like MySQL or Oracle or SQL Server. So the traditional join types, inner join, outer join like left outer join and right outer join, full outer join is also supported in the um, Hive. Okay, so if you look at the in general Hive concepts, so basically if you take this as right. Okay, so if you take two tables, if you want to join two tables, that should be a relation to join two tables, right? Say example, if you have a employee table and a department table, generally the department ID will be part of your employee tables. So the department ID from employee table and department ID from department table or the relation. So basically using that the relation key, you can make a join condition. So if the employee table is the table one and the employee table, the department table is a table two, it basically joining these two tables, when you do inner join, the whichever um, um, the department IDs which are matching between two tables, those records will be returned. So that is basically a inner join result. When you do a left outer join or left join, so basically all the tables from table one, which is a employee table, and those records which are matching uh, between the department ID from employee table and department table will be your result of your left outer join. And right outer join is a other way around. So which is basically all the records from the right table, which is like department table in this example, will be um, retrieved with the joining rows for the department ID. When you go for full outer join, basically all the rows from both the tables and also the joining um, records, right? The those also will be coming as result as basically all the records from table one table will be coming. So this is the like concept of joins in traditional systems. The same way in Hive also works. Okay, so the syntax are going to be like um, so for that I will take example of the customer table which I created, and let me create the order table so that we can actually write these joins and try the example. So let me go and create this table. Meanwhile, if you have any question, please ask so that I can answer that. Okay, let me start this. I will open Hive. Will open one more session. This is opening. Let me check the order table. Let's look at it here. Okay. In data, I have only customer. Okay, let me create orders as well. I created an orders directory, and inside data and Hive and subdirectories orders. So in Linux directory, I have data, which is let me move this order.txt. So basically, this has so this is for so the records actually um, represents order ID and the first column, and if second column is going to be order date, and third column is uh, basically the ID, right? Um, it's a customer ID, and then we have amount, which is order amount. So we have customers from uh, 1 to 7, I guess. Okay, so let me create this order table and load the data. So this is the Hive CLI where you can go and create tables in Hive service. So this Hive command line interface to check how many database available in your Hive system. Show database is the command, and I was using the database is a dm underscore hive underscore db. Use command to just change it to your By default, it will be a default database when you log in Hive CLI. Now you need to change it to DM Hive DB. Then just create this table. Okay, so so what we are going to do is we are going to create a table which is orders. Create table. If you are not using the keyword called external table, it is going to be managed table. And I provide the column information, and I mentioned the row format delimited fields are terminated by space. My data, if you look at my data, I'm actually each field are I using the space separator. Based on the delimiter use, we can actually change the delimiter and the lines terminated by /n. So again, this is stored as a text file. I'm using a text file input. So in general, the lines are terminated by /n, new line. So I just create this. So already I have a customer and customer managed table and the external table. So now I created a orders table. So let me load the data. So if you want to load the data into orders table, you can do two way. Basically, you can actually load using an insert command. You can actually insert row by row or multiple rows. Another way is to load using the load data and in path, where you specify the HDFS directory of your data and then overwrite into the orders table. I will use this because my data is already in HDFS. If your data is in local, then you can use the local and in path. This directory is going to be a Linux directory. Since I put it my data in HDFS, I'll use HDFS directory. It says no matching files. Where did I keep? Okay, so I have to put a file. Okay, I'll just put a file from here. Let me make sure that file is available. Yeah, 100.txt is available. Now I'll just run the load command. Okay, now the table should be having a data orders. Yeah, so this has all the 4 rows from the file. So if you want to print the, so if you see, actually I created a orders table with the 4 columns. Okay, but the data is stored, but by default it will not show the column, your table columns. You can access set a property called I CLI dot print dot header equal to true. So basically there are a set of properties where you can define in the command line and you can use it. So this is one of the property. Now you will see the table ladder has come. Similarly, I will also show you the customer table. Okay, if you look at the customer tables, um, we have 8 rows in customer. The customer IDs are ranging from 1 to 8, right? And in order table, we have data for customer ID 4, 2, and 3, right? So when you do inner join, it's going to return these 4 rows, which are actually matching. When you're going to left outer join, which I'm going to consider, um, so it's based on what table you consider as left table. I'm going to customer is going to be uh, a left table. You can consider anything based on that your result is going to change. Um, so customer is I'm going to consider as a left table and orders is a right table. So when you do inner join, your syntax is going to be like this. So you can select columns um, which are from the respective tables. So I'm saying from table 1, which is customer, and I'm just giving alias as C and join. Okay, so inner join is basically default join. You don't need to specify inner keyword. Join under orders, which is your right table, and you have to specify a on condition, which is a join condition by specifying on and provide the ID, the customer ID. Here ID is nothing but customer ID from both the tables. So this is going to perform um, inner join, right? So my basically the left table is going to be this customer table, which is going to return the matching, whichever customer IDs are matching from these two tables is going to return the value. So basically, out of this, you'll get a 4 rows. So it is going to generate a MapReduce job. So what happens is, so whenever you send a query, it is going to this is a ICLI, right? So as per our architecture diagram, uh, just check it. So the ICLI send the query to the driver, which in turn go and check the table information from Metastore, which is the basically metadata about your table is stored in the Metastore, which is going to be a RDBMS system like that. It by default it uses a Derby embedded database. Else you can configure MySQL other databases. I configured as MySQL in my setup, and then it's going to refer the uh, um, sorry, it is going to generate the for your query. It is going to get parsed and optimized. So finally, it will prepare the DAG in terms of MapReduce job as a map and reduce task, and it will run as a using MapReduce client. It will run into the Hadoop cluster. That's how it is happening in our case. And this got executed and returned the 4 rows, right? Uh, basically, you had 4 rows with respect to the matching customer IDs. Now, when you do other joins, like left outer join, again you're going to return the 4 rows. You'll not see much difference here. Okay, you can also go and basically monitor your jobs using Yarn dashboard actually, right? You can localhost. So English is also finished. Okay. Okay, so here all the customer table is going to be your left table, right? So all the rows it's going to come uh, like all those 8 rows, and whichever is a match, whichever the um, customer IDs are matching, those respective details going to come. So if you see the order amount and order date for customer 8 and 1 will be null because those customers we don't have data in order table, right? So basically, whichever's uh, information which is received, those customer IDs having records in order table. That's what you got this result. So when you do the again the right outer join, it is going to get the 4 rows from right table, which is order table, and matching rows from both the tables in terms of order ID. As please, um, uh, I yesterday I sent you one link to do the setup of um, Hive. Okay, you can follow this video. Um, so this is let me show you. So basically, I hope all of you set up this Hadoop on your machine, which is HDFS and MapReduce and Yarn. Uh, that is part 3 video does that. And once you have a local setup with Hadoop, then you can go and install your Hive component, right? So it is going to be a set of steps. So if you want to, I think I have, I don't know whether I have sent this. Okay, you can actually find out all the commands which used in the video are available in this link, or also I will send the uh, basically the so this is so all these commands are used to set up the Hive. I will send these commands as well. You can go and install it. Okay, go and install the Hive on your machine and please practice this. Okay, that's going to be helpful for you. Now almost inner join and right outer joins are almost same because we have only 4 rows from the right table. Okay, then let's run the last query, which is full outer join. Finally, it is going to work like your left outer join because both the tables records will come. Okay, so now let's this is run and we'll focus on the next concept. So basically, do you have any question on the join types or join concepts. Um, any question on join types?
No, sir.
All right. Okay. So the next very important concepts in Hive is partitioning and bucketing. Okay. Uh, what is the uh, uh, what is the uh, benefit of these two concepts? Going to improve your the query performance, right? So let's go one by one. What is partitioning? Okay. What they say is using partitioning, you can make it faster to execute queries on the slice of data. So basically, what we are going to do is a table can have one or more partition columns. In general, separate directories created for each distinct value combination in the partition columns. Okay, so this is one type of mechanism where you are going to segment your table data into smaller parts. Okay, so based on the partitions column. Okay, so example, if I have a um, so look at the our so this is basically your full outer join queries, which is similar to your left outer join because you don't have the other columns. Sorry, uh, this there is this order table does not have any rows which is not part of your customer table. So if you have records for customer ID 9, then you will see different rows, but here I don't have it. So that's why I'm getting the same result. This is fine. Now, okay, if this is getting closed, please use the same link to join back again. So let me select the customer table, right? So if you see there is a column called address, okay, which represent city, okay. So basically, it is basically this table. Example, consider this table is going to I run a retail company or e-commerce website. I store all my customer details across the versus for now just think of as a India. So I own a retail company and I have a stores across the India. Okay, so I store customers from across the cities. I just stored it in my table, right? So if I just it will be like so uh, more than millions of rows, right? So if I have a huge number of customers, so if I run a query, okay, take example, I'm going to run a query where my query is dependent of my query is always I uh, use the filter condition as so my query is going to be based on a filter condition city, right? So some of the queries I write, I filter uh, city. Okay, so I based on this I just do the as every time when I do aggregate or maybe the any queries it can be, I use a filter city, right? So what it is going to do, it is going to analyze all the records from this table, right? Which means it's going to do the table scan. So if your query is based on particular city which is a address here, uh, what is the plan is just to store your customers in terms of city, right? You segment your data, right? Your customer data, you create a segments based on the cities, right? So all the customer which is belong to Chennai, you create one segment within a table, right? That is called partition column, right? So you are going to create a partition on the column address. So what happens, so you can think of as a now entire data is stored on a customer. If you look at the the SDFS, I'll just go 192. This is I will go to the user Hive warehouse. This is the default directory for uh, data will be managed. The data stored on Hive manage or intent tables are managed by this location. The Hive will be managed on this location. I'll go here. I have a customer. Then if you see, say example, I loaded the first initially customer data. So now um, so here it is not. So we see all my the 8 rows which has customer data, all are stored on this customer directory. Okay, so instead of storing entire all my millions of customer from my retail store on this directory, if I create a partition on address which is city here, there will be a subdirectories, right? There will be subdirectories for distinct number of cities in this customer details. Okay, so there will be a subdirectory called Chennai, and under Chennai it is going to have all the customers from Chennai. So if you segment your data, so whenever you apply a queries based on your partition column, which is city, then it is going to look into this only the columns, only the segment of the uh, rows from that particular filter you apply, say. So then it is not going to look into the entire data, because it's going to, you specify city as a filter, then it going to look into the subdirectory of say city Chennai, then it will get the, it will run query on top of that and it will give you the result. So it is going to perform your the query execution faster. So that's how the we are going to do the partition. So for to design a partition column, you need to know what is your when you design a table. So how do you design a table? Basically, the partitions column is decided based on the queries how you perform on those tables, right? So and if you take a trading data, so most of the queries based on the so generally the query based on trading the trading date. So basically, some of the aggregates may happen on day wise. So you can use date as a trading partition column. So on a trading data, you can use date as a partition column. So mostly, if you people who have knowledge on data warehousing, okay, so the dimension tables, right, which are like customer, which is date, which is a store, or those tables, right? Uh, the columns which is related to those tables will be used as a partition column. Say like city, state, country, um, and basically these are the categorical columns. So the columns which has categorical value, right? Those columns is basically used as a partition columns. So how do you create? You can use there is a keyword called partition by. Using that, you can actually provide a partition columns. So I partition helps to increase the performance of I queries. Okay, now and there are two types of partitioning. Okay, one is a static partitioning. Okay, so you can define a static partitioning using this command. So I create a table, table name, and I define columns which is like a student and the basically student name and ID and marks. So year of passing I'm taking as a partition column. So partition by, and by provide the column name which is a passing year of passing out. In this case I'm using a string, and again other columns like row formats delimited 5 delimited fields are terminated by comma. Okay, so I'm using my data set will have a comma separator fields for each field, and other can be ignored because that will be taken as default. So coming back to static partitioning, and there is one more type called dynamic partitioning. So when we will use static partitioning, when we will use dynamic partitioning. So we know what is partitioning. Basically, horizontally slicing your data and making a smaller segment depending on a particular column, right? Which is can be any columns. Mostly it will be on categorical column. So basically in this example, what I took is I have a student. Um, Basically their results. Um, Basically each year people get passed out, right? So I have so basically student information who passed out the examination, uh, and I already the data is segregated based on uh, uh, the year of passing, right? So if already data is segregated and you have a data separately already segregated, then you can create a static partition. So the importance of static partition is when you load a data into partitioning table, you have to specify the partition value for the partition column, and your data should be segregated based on the partitioning value you pass. So this is for passing year 2011, okay, and 12 and 13 like that. Okay, so let us close this session and connect back with the same link, and we'll discuss further more. Thank you.